we got a huge box at City Hall that you can put your ballot in. And as I looked, you could see ballots piled up above the slot.
Oh, neat.
I mean, so great big box, and it's full already this morning because they emptied it last night.
Yeah.
So
I think a lot
anyway,
of people are considering this the most important election ever.
I've heard they're going to have like what, 90% turnout in Washington.
Wow.
Yeah, that's unprecedented. I see Siddhartha's joined.
Great.
Nice.
My microphone off here.
Yeah, it's all good. Let's see. Let me turn my volume up. When my volume's down, then I end up shouting at the computer for some reason. There we go. Hopefully it won't misbehave. Where is the volume? There it is. Okay. Nice. What do we got? 12 noon, just like that. You guys are on time.
How do you access the volume?
Oh, well, it's just on your PC. Well, I don't know what you're using. I'm using a PC.
I'm using a Mac right now, which I don't normally use.
Okay, so wherever you adjust the volume for your Mac normally.
You'll have to think about that.
Yeah.
How does it sound right now? Do I sound too loud?
You sound great. Yeah.
Good, I'll just leave it like it is then.
Yeah, I was adjusting my playback volume so I could hear you guys. I had it turned way down. Hi, Renan.
Hey, hi, Dana.
Hey, there you go.
I believe Terry is attempting to get on.
Okay, well, hopefully it's easier this time since I didn't send out the wrong number.
Yeah, no, I mean, it's just that he can't find his emails. So,
Okay, well, whatever works.
yeah, so I think he'll be on shortly. I resent the email just now to him.
Oh, good. Oh, good. Yeah, I apologize. Last time I had sent out the invitation and it had the numbers that I intended to use. But when I set up the series of meetings, it rotated through meeting numbers automatically instead of using my personal number. And I didn't notice that. So the invite at the top of the message I typed in didn't work, but at the bottom of the message where I cut and pasted it in, that did work. That's why there was like a 50% hit rate. But
Great.
Anyway.
I sent a message to John Ferguson and Jay Hope and Mike Drez, asking them to join this, inviting them to come on this morning. I sent it this morning, just sort of like a reminder, but I don't know if they were, I never heard back from them, so I don't know.
Yeah, well, that's cool.
We'll see.
I emailed with John Ferguson last weekend, and I think he said he was going to be out of town, out of Spokane town and in Seattle area this week.
Oh, okay.
So I'm not sure if he's on the road or busy with other stuff, but
sure,
he may not be able to attend, but
all right.
Yeah,
he will if he can, though.
Yeah, that would be good.
Yeah.
Well, I guess we might as well start talking about whatever we want to talk about. It's after 12, so people are, I don't know. I don't have anything in particular to myself to share audio wise. I did buy a motorhome, but so I guess it's got speakers in it.
So Dana, where are you with those speakers of yours? Are they still, I mean, have you mounted them on the wooden baffle or what?
Well, my huge advancement was acquiring the required screws.
Oh.
So that when I had free time, I realized you need to use these countersunk screws to mount, because they mount from behind. The mid-ranges mount from behind, so you have to get exactly the right thickness of wood and then drill the 4 holes in very precise locations and countersink them. So it's a little tricky. There's
Yeah.
Howard. And so I have been, so yeah, the drivers have just been sitting here while I was out digging in my yard trying to get my shed done before winter. And then I got distracted with buying an RV. So
I see Siddhartha has joined us also.
yeah, we don't have his picture, but
Siddhartha,
that's okay.
we can't see you and we can't hear you. Have you got the mic turned on or something or not?
Looks like he's just muted,
Okay.
so that's okay. But if he wants, maybe when he gets.
I'm there. I'm there.
Oh,
Okay.
excellent.
Video is not there though. Is that how you want it?
Oh yeah, I have to go move around this morning doing various
Okay.
things and listen. So
Right. Okay.
the backdrops won't be very interesting.
All right.
He's at his new dance class, so he didn't want to share. Yeah.
So, what else is going on? I got. Let's see if is there a way to reverse the video? Yeah, there is. So I got one of these units a while back. What it is that upside down? Yeah, that's upside down. What it is it's you can plug in HDMI video, an HDMI source into this little box, and out the other end you can get
Oh, nice.
you can get coax digital out for your audio. So in other words, if you're watching a movie on your big screen, but you want to hear the sound on your big system, that'll let you do that. You can feed the output from that unit to your DAC.
Nice.
And you can pass HDMI signal through it, and it'll extract the audio portion and put it out as SPDIF, which you can then feed to your DAC. So I thought that was pretty cool because I subscribe to the Seattle Symphony, and now everything is live streamed. The concerts are live streamed. So instead of watching the concert on the computer and listening with the computer audio, I can now plug it into the big screen TV over there with the speakers and sit back and watch the whole production, with the best possible sound. That was the idea. And I tried that out and it worked really well, actually. I think that unit can be had on Amazon for about $10 or $15 or something like that. So it's pretty reasonable. The one I got it's called an HDMI converter.
Okay.
So Renan, that has a DAC chip in it?
Yeah, it has some sort of a chip to extract the digital signal from HDMI and put it out as SPDIF. So it's not true.
Oh, okay. It doesn't come out as analog.
No, it doesn't come out. Oh no, wait, it does come out as analog also. It gives you both choices. Here's the analog portion. That's analog right there. So you can choose to have a digital out, coax digital, SPDIF, or analog, whichever you choose. I happen to like my own DAC, so I just extract the digital signal, and plug it into my DAC, and then out into the big system.
Right,
And
that would be useful. That would be useful for kind of even a low-tech used equipment kind of thing. Like at Darcy's house, I used an old receiver that didn't have an HDMI input, but we wanted just to use it for TV viewing, and
Right.
I don't remember what we did, but something like that.
Yeah.
Either that or the TV also had analog outputs. But I remember at one point we were kind of stuck because we didn't have an HDMI input. So that would be perfect.
Yeah, that worked really well. It's called HDMI Converter, and it doesn't have a brand name on it or anything, but I'm sure you can find them all over the place there. Yeah.
I did an
But
interesting experiment
anyway.
with one of those too. And I used it on I have a Schit Moode ladder DAC,
Yeah.
and it has several different kinds of inputs. And I was using it with a USB input from my computer.
Okay.
And it was always kind of bright. So I took one of those so that I could try the spiffif
Right.
input, and it did improve it quite a bit.
Yeah.
Yeah.
It's kind of
Yeah.
cool.
It sounds pretty good.
Effects
The streaming version from the live signal. Yeah.
Hey, I just wanted to welcome the other Dana to the meeting. Not that many Danas in the world, and we, you know.
Have as many as you can in a meeting, sure.
Exactly. How are you doing?
I'm good.
Oh my gosh.
My son and his wife just got over from Germany, and so my wife and her are out shopping today. So I'm kind of excited. It's good to see them.
Oh, fantastic. Wow. Man. I was going to jump in on Renan's thing there, because I had a similar thing that I found this week. I'll share my screen. There we go. So when I was trying to figure out how to send video to a distant TV from a HDMI source, it only had an RF cable running across the rooms over to this other TV.
Right.
And I thought, gee, wouldn't it be neat to send, you know, make a TV channel for my HDMI signal. And I found a modulator that was, in the $25 range.
Okay.
And that was all I thought existed, but that only worked at very low resolution. And so I did some more searching, and I found this one, which actually does the full 1080p. So you can, plug in your HDMI, and it'll actually does a feed through, so you can, put it between two components, and then it gives you the RF, and it puts it on the whatever channel you want. And so you can then also feed this between, you could have an antenna coming in, go through this, and it'll just add the channel to the feed, to whatever existing feed you had in your house, and look at your thing remotely. So I thought that was kind of cool. Unfortunately, it's $479. So.
Wow. So let me understand this right. So you're able to send HDMI from one place in the house to another through a coax cable.
It adds it to it makes a high def TV channel.
Oh, it makes a high def TV channel, which can then be carried over the coax.
And it just adds it into the mix. So you pick a blank channel, and then you can just take your cable or whatever you've got and plug that in here. This will add the channel into the mix.
Wow.
And then send it along its way.
Wow.
So it's kind of powerful if you want to, have a source in one room, and then.
For example, you're adding it to your set of channels that you get from some cable TV provider or something?
Yeah, or the antenna. Yeah.
Or the antenna. Okay.
Yeah.
I see.
So this happened because the RV had a DVD player in the front, and then it happened to have a little TV all the way in the back. That was, and the only cable that ran the length of the vehicle was the antenna cable.
I see.
And so the guy had done it, but he did it with this cheapo $20 one that did, whatever, standard definition TV. So I got back there and I'm looking at the picture. I'm like, boy, this picture's terrible. And then I looked around to see, well, can't you get a high def one? And I'm like, oh, this is why he got the $20 one, because you know, like
Oh,
he decided not to spend, I mean, for $479, you could also buy a really nice DVD player and just put it there.
right, right.
But it was interesting. I didn't realize that, you know, these existed and they're fairly sophisticated apparently. And
Wow,
but anyway, yeah.
that is interesting. Yeah. Huh.
And what is CATV is probably cable TV, right?
Yes.
And then what are the other ones that were there? Now the image is gone, but
Oh, I'm sorry. Let's see here. So it just had RF in and RF out, HDMI in and HDMI out. So there's not a lot to it.
but there was some other things there. I just thought I'd get educated here.
Oh
It's a
yeah.
QAS or something, and then another four-letter designation, different formats.
Oh, I see. Yeah, it converts HD audio video signals from any device into DVB-C/T/ATSC. So apparently you can configure it to modulate in different ways, probably for different countries.
Oh, you think those other ones maybe from other countries?
I think we use ATSC.
Hmm.
Yeah, I'm not totally up on that, but that'd be my guess.
All right.
Yeah, I mean, we just use one of those. DVB-C might be, I don't know. Some more globally oriented people might know. Hey, we got David Leonard. Welcome.
Hi, David.
Good day. How are you?
Yeah.
Yep.
But,
Yep.
Well, I've got a project going. Maybe you guys can help me with it. I've been living in the past by having my DAC connected directly to my computer. So I wanted to move up from that. So I looked around, and a lot of people seem to like these Pi-oriented devices. And there's a company called Allo. Do you guys all know Allo?
yep.
Yeah.
Wait, no, I don't know what that is.
Okay, well, Allo is a company in India that is,
Oh, you mean the plant aloe?
well, I don't never heard of
No, it's a company. It's a.
Oh.
I think it's.
Okay.
Aren't they a French designers that manufacture the stuff in India?
I'm not aware of that, but it wouldn't
I have
surprise
no
me.
idea.
Yeah, that's an
Yeah,
Allo
here's an
device.
Here's an example of an Allo DAC sitting on a Raspberry Pi.
Oh, I see. Okay.
So this device I bought they call it the US bridge. And what it does is it takes this Pi and they've isolated, they put the Pi on a bigger board and they isolated all the power supply components, lots of capacitors, and they split the USB input, which is normally tied to the Ethernet input. So they made a big deal about separating the noise between those two sources. And then you have all these different programs you can buy, which you put on a little tiny chip, and you stick it in there, and you can, all these different operating systems. I chose the Moode operating system. And so it takes a while to get through all the programming. It feels more like a DIY project than just something plug and play, although they claim it to be plug and play. It takes a lot of setup work. But I got it to work, and so it's broadcasting. The device itself is on the net, and then you hook the USB plug up to your DAC, and that's what gets the music to your stereo system. And I was hoping for a big improvement, and it worked. It really made a big difference. Very smooth sounding, much bigger sound stage. You can hear, especially into the mid-range, you can hear a lot more detail. So you have your choice of buying all these different power supplies for it, anywhere from like 20 bucks to 200 bucks. And I bought the one in the middle for about 70 bucks. And
So I'm sorry, I didn't quite follow that. So this device that you have, is it a streamer, or is it something that cleans up the USB signal, or what does it
it's both
what's
those
general?
things. Yeah, it's a streamer, and it's the main reason I bought it was to reduce the noise that's coming directly from the computer. Now I
Okay.
don't use the computer anymore. I
Oh.
just use this device as I used to use the computer.
Right.
And what I mostly listen to is Spotify.
Oh,
So
I see.
now I go on to my Spotify program, and it gives you a list of devices that you can control from your tablet. And one of the things that appears there is Moody audio, and that's coming from the Allo device.
Got it.
I click on that, and then I can run Spotify just like I used to do with the computer.
Right.
But there's
Right.
no direct connection with a wire between the
Yeah.
computer or the Allo to the DAC anymore. That's coming through the net.
Got it. Yeah.
Yeah.
So it is a streamer. Yeah. But and also cleans up the signal.
Right.
That's interesting.
So the next thing I have to figure out, I can do Spotify fairly easily, but I want to do some high def stuff. So I
Right.
get Tidal or something like that. And that
Yeah.
works in an entirely different way. One of the problems I'm having is that, you put in a web address on your Android and it brings up the Moode program, but it won't do it on my Android. I can get it to work on my computers, but
Right.
I can't get it to load up from the Android. So that's my next big step. And I have to
So-
do that before I can add Tidal or Cubase or whatever I decide to do.
There's a program
what
called there's a program called Volumio, but they charge you a monthly fee, and then they have the hooks so that you can run Tidal or Cubase on your Pi. I had to go the other way. I'm using Amazon, and I had a Volumio before with Spotify, but I have Amazon HD Music, and it's only a PC program. So at first I was using a Chromecast audio with a SPDIF to my DAC. So what I did was I bought a little fanless PC and plugged it directly into my DAC, and then I used remote access from my PC to it, and I used it to play my Amazon Music or my local hard drive.
Yeah, I think that I'm gonna have to do something like that. And that's all totally new to me. So that's gonna take a little bit of work to make it happen.
So what was the cost of this Moody device?
It's $350,
Oh, okay.
but you can spend a lot more money on it if you want to. They make a thing called a hat that you put on it, and that changes it to a spit-if out, and that little device will cost you another $350. And of
I
course,
see.
you could buy the $200 power supply, so you're pushing like 800 bucks if you go the whole route.
Okay.
The new Pi 4 bypasses that. The USB is supposed to be pretty clean just directly out of a $35 Pi 4. They've separated the Ethernet and the Wi-Fi from the USB. I haven't tried it yet, but I used the SPIF before. I used the SPIF board on top of a Raspberry Pi 3 to my DAC. But I think that for me and my DAC and my system, the USB sounded better.
Yeah, I bought a Pi 4 a few months back, and I thought, oh, there's all this talk that it needs fans or a heatsink or something. So then I also purchased a metal box for my Pi 4 that had the box acts as the heatsink.
Mm-hmm.
And after I got it, I realized it also it's a Faraday cage, so it blocks the Wi-Fi.
Oh.
I felt so stupid. But of course it's gonna, but I don't know, they made very little mention of that in the advertising for the metal box. You'd think
Can you cut a hole in the box and get enough signal?
Well, what I did is I bought an external antenna,
Oh.
and there's a place on the circuit board where you can solder on a socket, but it's not entirely clear to me where to cut the trace to the existing antenna from the socket. Anyway, RF stuff can be very subtle. So anyway, I haven't done the surgery on it yet. I'm waiting for somebody else to do it and post that they've been successful. But I have all the stuff. You could buy an antenna for $5 or something from DigiKey. A nice little whip, like you'd see on a router or something. You can buy those plastic antennas with a little cable and a little connector, and it will snap right on there. But you just have to solder the connector on the Pi 4 for the external antenna. And then I'm sure it'll be fantastic. And I mount that on the outside of the case. But in the meantime, it's, it was just an irritation. So yeah,
I have a question for Dana. You were talking about Volumio and your Pi setups and stuff. The Volumio that we downloaded for my Pi, other Dana and I downloaded for my, is not there's not a fee associated with it. Can you make the distinction between the one that has a fee and the one that doesn't?
Yeah, so they're slightly different. So the one without the fee, you can run Spotify and you can run all your digital stuff. But if you want to run Tidal or you want to run Qbuzz, it has to be cloud-based, I guess, or something. So there's more to it, and because they're doing that, there's a fee, a monthly fee. Now, somebody just sent us an email that says you can get the one for the monthly fee for $200. It's a lifetime.
Right.
So for $200, you can buy Volumio, and then that will allow you to get Qbuzz and Tidal. Plus, I think there's some other things it does also. But those are the two major features for me. I just didn't use those. I'm using Amazon Music, and there's nobody has a hook for Amazon Music yet for a Pi.
Oh, okay. Yeah.
Well, the Moody will do that without a fee. You can do the Tidal, and you can do the what's it called again? Qbuzz.
Oh, really?
Qbuzz, yeah.
Yeah, you don't have to pay a fee.
Oh, wow.
Can I ask a question of Dana as well?
Which Dana?
Sorry, Dana. The other.
No, you go for it. I understand. I just messing with you.
Dana too, I guess. Sorry. And, the question that I have is, I opened an account based on Jeremy's email, and so the free account, does that, if I have a Raspberry Pi DAC, like an Allo DAC, does it walk you through how to get Spotify onto your DAC? Because it's just kind of, go ahead.
No, yeah, it's real easy. It's just a plugin. So one of the options, so if you go to on the menu and you go to plugins,
yeah.
There's two Spotifys. There's a Spotify Connect and then a Spotify Player. And so you just say, yeah, I want these two, and they just come up, and then you put your login and your password in, and it shows up.
That's good, because when I first downloaded this and set this player up, it was impossible to do without some sort of guidance. And so I went to this one user group, which I know they're all useless, and I got absolutely no response. So anyway, okay, well, that's good to know. So I can at least get Spotify for free now that I have this Volumio app, right?
Correct.
Cool.
Which is also on the free app. Now,
Right.
if you paid for the app, then you can also, the same thing. They have a Tidal plugin and also a Qbuzz plugin.
Understood. And then I would imagine you have to pay the extra $13 or $14 for Caboose every month too.
Correct.
To them. Right.
Correct.
I understand.
So yeah, you have to have a paid account. Spotify has a free account.
Right.
But that doesn't work. It only works with the login.
Understood. Okay. Thanks for your answers. I appreciate it.
Sure. Thanks.
One other question for Dana North. You're in Everett, right? Somewhere like that?
Yes. Yeah.
Is that if you know or somebody else knows, if you can compare and contrast the features of Volumio as a software package and an interface versus JRiver, and I'm assuming that JRiver has a lot more different functionalities and things, but I haven't really used it.
JRiver I don't know about. I've looked at it, and the JRiver will work on like I said, I don't know. I've kind of looked over it, but I've only used Volumio, and then I use Foobar, are the two things that I use.
Okay. So I use the Volumio in a very simple way, and I have to give my thanks to you because I think there was a chain of information that went from you to other Dana when we were at Dave DeLuga's place up in Victoria, and then Dana got the Pi server worked out, and I don't remember what you were recommending, but I ended up using the Allo. I guess it's a hat. It sits on top of the Pi 3, the Allo Boss stack. Ended up using that and made a nice little server out of it, and it's been pretty trouble-free. I also bought their Class D amplifier. I think you call it a volt amplifier, and I don't remember how many watts and stuff it is, but for $40 amplifier, it's kind of amazing. So anyway, thanks to you for I think you kind of helped initiate other Dana with that. Was that true, Dana?
Yeah.
Oh,
well,
yeah.
yes.
Yeah.
Yeah, we
Yeah, between. Oh, go ahead. Go ahead.
No, Dana, go ahead. No, Dana, go ahead.
I think John Ferguson was also in on the deal. I remember I got a picture of you two guys talking over there at Dave Beluga's. But yeah.
But it's been great. It's been great for me. Yeah, I built some cute little wood boxes and mounted a little headphone preamp, and then the little Class D amplifier and the server all on one little box and a board, and I think it'll about fit in a shoebox basically. And then then it has the external switching power supplies, just cheap power supplies. And we had it set up at the DIY sharing time, and it didn't sound as good as Rene's really nice hybrid amplifier that he had. It's stepped down from that, but for the price and all, it's amazing. The Class D amplifier really did a pretty good job. That's pretty amazing that you could get into that level of hi-fi for a few $100s. If a young person was starting, or somebody didn't have a lot of funds or whatever, and it's amazingly compact. And of course, I'm just using the server not as a streamer, just as just operating off the USB chip with FLAC files, and for a few $100s, it's like a complete playback system, and then just rip CDs onto it from the computer onto the USB drive. So anyway.
It's also a DLNA host, so if you have music on your PC, you can connect it over the network and actually play your music from. So if you can plug a hard drive into it through like a USB or to your NAS, but it's also DLNA, so you can find it on the network and use it as a streamer inside your house too. Which
okay.
I did that a lot.
Okay. Right. So if you have files on your computer you don't have on the flash drive or something, you can.
Correct. Yeah.
Right.
Thank you very much. Okay, I'll talk to you later, and I have all my apologies arranged. Okay.
Hey, Terry.
welcome, Terry.
Hi. Can you hear me?
We can hear you loud and clear.
Oh, I'm sorry.
Oh. Oh my gosh. We've been talking Raspberry Pis.
Oh, hey, great.
You sound delicious.
Yeah.
Yeah.
Oh, hey.
Hey, Captain.
Oh, check this out. So I actually have evidence. Let's see, share. There we go.
Ah, yeah.
Oh, I know that guy. I even know that house. Yeah.
Yeah. So that was some Raspberry Pi knowledge being shared.
Yeah.
So that was pretty cool. We were. I wonder if you guys will be able to hear the.
Oh, I'm wearing my Hawaiian shirt. All right.
Yeah.
Yeah. In the
There you
Jimmy
go.
Buffett vibe, I guess, huh?
But yeah, so there's.
Oh, I remember that.
Yeah.
I remember all the cars took off while we were in the snack bar, and I went out and my van's sitting out in the middle of the pavement.
Nowhere.
On the tarmac with
Yeah.
run
But-
and jump in it, and the polite Canadians didn't even give me a hassle about it.
Yeah.
Well, there we go. I can back in the good old days when we used to go places and do things.
Right.
Yeah.
So anyway, I'll I can now if I can get control back over Zoom again. There we go. I will return to the normal broadcasting. Oh, there's Terry.
Hey.
He's in the aluminum tunnel again.
Yeah.
Nice.
But it stays steady, doesn't fall over all the time. That's a good part.
There you go.
So what's the verdict on the Raspberry Pi? Is it a good deal?
I think so. I mean, if you can find the you kind of study all the things you can do with it, between the there's different music streamer software, gosh, 5 or 6 of them, I imagine. Sounds like I've used Moode, and I've also used the Volumio, and but I got 2 of them streaming music successfully. One with the Boss DAC, and one with the digital output, where you hook up your whatever DAC you want. But yeah.
Okay. Wow.
One thing to watch out for, apparently, with the Raspberry Pi, I mean, there's people in the club. One guy in the club, since he's not here, I won't talk about him by name, but was really turned off to Raspberry Pi because he had an early version of a DAC for it, and he just said it just didn't sound very good at all. And I guess Raspberry Pi is standalone. The DAC that's in them, or however that works, is pretty poor also. And not knowing really about it technically, but knowing the kind of advertising words about it, the advertising hype about it, is that the Boss DAC is supposed to reclock the Pi. I guess there's an unsophisticated clock in the Pi, so it really didn't keep track of the bits very well, and so that the Boss DAC somehow brings that up quite a bit in sophistication. And so if you get like a cheap deal on some other DAC that is a hat that nests on top of the Pi, you could end up with kind of mediocre sound. So there's good DACs and bad, and really a wide difference there apparently.
It just occurred to me, it also has HDMI, so that box we talked about earlier, you could just plug the HDMI audio extractor in there, and people do that as well with these. So that's kind of another way to go.
We'll have a very basic question maybe somebody can help me with on this subject. When I'm trying to set this thing up, in the menu, there's a section that's labeled MPD, and I have no idea what that means. Do you guys know what that means? Wow.
It's Miller time. Miller Genuine Draft.
Wow.
Yeah, okay, that's good to know. I looked it up on the net and it's just a bunch of great big words I don't understand, so.
I have no idea.
And so that was in Moody, or was it in?
Yeah, it's in Moody.
Okay.
Are you gonna look it up?
I guess so.
So I feel a little bit in the wrong group with all the Raspberry Pi talk, because I've been using different stuff for streaming, but I thought I'd show you a different kind of thing that Raspberry Pis can be configured for. This is ASI Air Pro. It's actually, I'm starting to get into astrophotography, and this is, you can't log into it like a computer, of course, but it's been designed entirely to control a telescope, control the tracking, do the plate solving, and do a whole bunch of different functions, control the camera that you would have associated with it. So anyway, it won't play any audio, but it's interesting that they get all that in one little thing.
But you said it's based on the Raspberry Pi system?
Well, it's basically a Raspberry Pi board, and then the software that was packed around it was all intended for that function. And of course, that's what the Raspberry Pi was all about, was to be able to have dedicated
you can
freestanding devices.
Right, yes, exactly. Cool.
But as far as the streaming stuff is concerned, if anybody in the club is not already aware, I've been using kind of a different approach than the Raspberry Pi. I kind of started out with, the JRiver on a built-up fanless PC, but then switched over to trying it on a Mac Mini, mostly because of user interface issues. But eventually I've migrated. I've been using now for some time, and I'm really liking it. It's a combination of the Exasound E20 DAC and Exasound PlayPoint, which is actually a purpose-built Linux device that it has a proprietary mode that it takes advantage of when it's used with their DAC, but it's actually a USB connection. And then I have been using Tidal on it and plus local files for a while, but I ended up breaking down and getting the Rune lifetime thing, and the Rune ends up taking the Tidal. I also have Qobuz, and then my local FLAC files are on an SSD that I have plugged into the PlayPoint. And then Rune organizes all of that. And so I kind of like the user interface for it, but it's up and running.
Cool. Wow.
And I got my crossovers done.
Oh, nice.
Yeah. In fact, if I can screen share, I could show a picture or so.
Oh, yeah. See if I can figure out how to enable that.
Okay. Well, I've got a button for it. So.
Oh, go for it.
All right, let's see. Host disabled participant screen sharing. That's what I got.
Okay. Let's see what that does. Try it now.
Okay. Okay, now it's giving me something. So there we go. You see that?
Yeah.
Yes. Oh.
All right. So let's see. I don't know if this will let me change pictures. Okay, yeah, there's a different perspective. Let's see. Oh, yeah, there's the power failures.
That's the high level perspective.
Yeah. Okay, this kind of shows the autoformer. It's a Dave Slagle thing that's in the high frequency section. At the top, you've got the, this is the CLC. That's the crossover for the ribbon tweeter. And I'm taking a tap off of the autoformer for that little copper alligator clip there. And the unused taps are all folded over, but this is the main one that I'm using to go to the outputs. So let's see. There's another view of that. That's below that on the high frequency side. And let's see. Yes, these are those Jupiters on the woofer section side that are, let's see, I think I had a picture here somewhere which showed a, there we go, a milk carton, so you can see that's
Wow.
a half gallon. So
Right.
So you got
Gary,
a
when you're
a 2 gallon
referring to that, when you're referring to the high frequency section and you say a CLC, you mean it's like a third order passive? Is that what you're talking about?
Yeah, all this
Okay.
is passive. It's a third order for the ribbon tweeter is up here. The compression driver has also a third order, and then with the autoformer is at the output, and that resistor is in parallel with it, which terminates the impedance. And then the woofer section is LCL, and then this is the Zobel right there. And this view is upside down actually, because the thing sits on top of the low bass cabinet behind the upper woofer, and kind of fills in the rectangular cross section of it. And then this cable that's just hanging down there, you see that connects to the terminals of the woofer, because it's just outside the woofer box. That's kind of the idea. And crossword puzzles, yeah.
I have to do a spoiler alert on the crossover.
It's a good beer.
Yeah, so it's a 2 gallon crossover.
Yeah, and it's nice to have music playing again. So it's things were dismantled for quite a while because I had to get some of a couple of the parts, the autoformer and the inductor in the high frequency crossover. I needed to reuse those, so it's been out of commission for a while.
Yeah, wow.
Dave Rosegard, if Gary's, did you finish, Gary?
What's that?
All right, do you have anything more to say about that? I was going to ask Dave about his three-way he's been working on.
I'm done.
Okay.
Oh, an autoformer, just for the, I don't know what that is.
An auto transformer is, instead of having a primary and a secondary, it's a single winding on a core, but it's tapped. And so if you feed your signal in from the top, then you can take proportional outputs. So it's used as a step down.
Oh, okay. Thank you. All right. I'll shut up now.
Yeah, it's an interesting thing because it's like a big inductor with a bunch of taps in it, and so you think instead of using a tapped resistor or like I guess it's like the inductive equivalent of an L-pad.
Well, the thing is that it steps down the impedance.
Yeah,
and it has some advantages. I kind of compare it to the idea of using a transmission gears to change your impedance instead of riding the brake.
Yeah, so it's not wasting instead of like an L-pad that just burns off the energy. It's acting like a transformer, but it just doesn't have the separated windings. So
yeah, because you're not needing to isolate grounds. So
yeah, they're pretty cool.
So this is a question I've never really quite got answered, and you might know, Gary. Somebody else might know. In a second order low pass where you have a cap that goes from positive over to negative, where does that energy go? Is it energy that's just burned off, or is it does it reduce the demand on the amplifier in that frequency range wherever it's not passing current to the driver?
Well, the capacitor has a let's see, you got to keep these straight. You know, with resistors and capacitors, they kind of are opposites in terms of where they have which end they have high impedance and which end they have low impedance. And the capacitor, of course, has infinite impedance to DC, but lower frequency, the bigger the capacitor, the lower it goes, it rotates a curve. So, but basically, in a crossover, you're kind of shorting the excess energy to ground, aren't you?
It would seem likely that it would be that way because it's.
When the impedance is going up, then the energy isn't passing.
So when it gets shorted to ground, but I mean, are the capacitors just sized large enough that they dissipate the heat? Is that current? I mean, does the current go off as heat in that component or in the amplifier or somewhere? Not in the amplifier, because you ever hear about amplifiers having problems with crossovers unless it's real low impedance.
Yeah, I'd like to hear Rene.
Yeah.
Rene.
Yeah, well, a capacitor doesn't actually pass any current through it.
Sure
It
does.
charges and discharges. Oh, here's Rene. Yeah.
Yes, it passes current.
Well, not through it. It'll just charge and discharge, but it won't actually have a current go through it.
But you got to remember, it's not nominally a lossy device. In other words, since the voltage and current are out of phase, it's a reactive component, so it just doesn't dissipate power except in the lossy parts of it.
Right.
The lossy part of the capacitor would be the series resistance, and if there is any shunt resistance in it, which usually is extremely high, so it doesn't matter. So the capacitor, all it does is exchange energy from one cycle to the next. Just so does an inductor, except an inductor usually you can look at the losses more easily because there's usually a fair amount of resistive loss in an inductor, and there's core losses which look like a parallel loss. But a capacitor, just because it's a reactive type, doesn't dissipate energy. The only thing you have to be concerned about in crossovers, of course, is whether the capacitor can handle the current, because the reactive current can be fairly large, although it's out of phase with the voltage. So that's why they're physically fairly large. It's also a lot of capacitance, so that makes them physically large too. So, anyway,
I can add something to
add something, Dave.
Go ahead. If you look at the overall crossover circuit, it depends on where the capacitor or inductor is. They kind of act like a valve in that if the signal is going to go through it, fine, it'll go on to the next components in that chain in the circuit. But otherwise, say on a capacitor and you've got a low frequency that's not going to go through it, the capacitor is going to block it and it's going to go upstream into other devices that won't have as much impedance or reactance. So it's kind of depends on the circuit that you have, where the signal is going to go. The capacitor or inductor will either pass it or block it. So you have to look at the rest of the circuit to see where the signal's going.
Well, you can think of it more as a proportional device, because the capacitor impedance, or whatever, decreases with increasing frequency. The inductor does the reverse; it increases frequency. So if you look at the two in the crossover network, you see that they're both working together, at least in a second-order network. In a first-order network, of course, the capacitor or the inductor is just working against the resistive component of the loudspeaker. But you think about it, the capacitor basically gets lower in impedance at high frequencies. The inductor gets lower in impedance at low frequencies, so they just go in the opposite direction.
So you can kind of think of them as filters. And in fact, a lot of times a crossover is called a filter network because of that. So.
Right. It is a filter, that's correct.
So here's a theoretically, if you were able to measure all of the all of the power that an amplifier was putting out that was connected to a loudspeaker, and you're able to measure all of the energy that was coming off of the loudspeaker into the room. And would that proportion, would that ratio between amplifier output and speaker output be the same? I guess, I don't know. I mean, maybe you never make a crossover that just has a capacitor, so maybe there's no way to answer this. But because Rene, you already said there's losses in an inductor from just resistive losses. But would you have an amplifier, say, putting out 10 watts and then a speaker putting out 0.2 watts into the room or something like that? Or 0.2 watts of audio power is probably putting out heat too. But would you put the crossover in there and the amplifier is still putting out 10 watts, would you still be getting 2 watts out of the speaker, or would there be some energy being dissipated somewhere? It's coming out of the amplifier but not actually coming out of the speaker.
How much heat?
Nothing ges lost. But
yeah, I think Howard, what happened? Oh, go ahead, Rene.
Yeah, well, assuming that the capacitor is a very low reactance, i.e. you're within the pass band, then all of the amplifier power is, almost all of the amplifier power is going into the loudspeaker. And what doesn't come out as sound is going out as heat in the DC resistance part of the voice coil.
Right.
I mean, loudspeakers actually are pretty inefficient. The one you just mentioned, of course, is 2% efficient, which is actually fairly high for a direct radiator loudspeaker, in fact. So 10 watts in, 9.8 watts will go into heating up the voice coil. If you're in the region where the capacitor is rolling off the low frequencies, okay, then you won't deliver 10 watts into the speaker because the impedance of the whole circuit will be rising. So you'll be delivering less actual power, but you won't be throwing power away in the capacitor. Whatever reaches the speaker, most of it will get dissipated in the resistive part of the voice coil. So anyway.
So if you had a speaker directly hooked to the amplifier and it's putting out 10 watts, and then you put a capacitor in series with it, well, the amplifier won't be able to put out 10 watts anymore because it's not loaded over the whole frequency range. So now it might be putting out 1 watt because it's only able to dissipate any power into the high frequencies. So the power's not getting there, but it's also not getting drained out of the amplifier. The amplifier might be swinging the same voltage, but it's not loaded.
Right. Power is times current.
Yeah, so there's no current flowing, even though the voltage is still there, because the capacitor's got creating this high impedance at the low frequency.
Oh, wow. Right. Huh. Okay. Well, thank you. Thank all of you very much for that. Dave, did you want to
oh yeah,
give us a final report on your three-way?
Well, it's been a week or two since I did anything on it, but I had one last resonance that I had to finally address. I added one more parallel notch filter in series with the tweeter. There was a really annoying little shrill resonance. After doing some measurements and zooming in on it, I realized it was around 8,500 hertz, and certain female singers and certain piano tracks, when they'd hit that note, you could hear it was a little bit shrill and it was a little bit annoying sometimes. So I went about designing a parallel notch for it, and it took me several days to really hone in on it and get the exact combination, and it finally worked. And I got rid of it, and I had because we're in a high frequency, 8,500 hertz is fairly way up there, and to make a small notch like that, the little resonance on the with the microphone measurement was only 2.5 or 3 decibels above the rest of it. So I was trying to tame that little tiny thing, a very narrow little notch. And I had some 0.02 millihenry. That's 20 microhenry coils. I think that was 22 gauge on it. And the cap, I think, was around 14 or 15 microfarads, you know, a large size for that small of a coil. But that tamed it. And then I thought, well, I did have some larger gauge coils. I think I had some 18 gauge coils, and I unwound them down to the value. It turns out my woofer tester or DAT system that I have doesn't go down all the way to 0.05. Anything below 0.05 millihenries, it just says, oh, it's less than that.
Oh.
So, but it does have an impedance sweep that you can plot on the graph. And so what I did was I took the 0.02 millihenry coil in the 22 gauge, and I made the measurement of that and saved it on my screen. And then I started unwinding my larger gauge coil and measuring it each time I unwound a little bit until the two curves matched on top of each other. So I knew I had the same value at that point. And so I had a larger gauge coil, and then I went and got a better quality cap instead of the electrolytic that I was using for testing. And I put that in there, and it cleaned up the sound quite a bit. The resistance on that little coil was about half of what it was. It was 1/10 of an ohm with the 22 gauge. When I went to the 18 gauge, it dropped the resistance of that coil down to 0.05 ohms, so about half. And that little bit and the better quality capacitor that I put in there really cleaned up the sound, because I had to put this parallel notch in line with my tweeter. So there's a series notch that you can put in parallel with the driver, but since my notch was at such a high frequency and so narrow, the high frequency wouldn't have been that big a deal, but since it was such a narrow little blip, I had to put it in line to really feasibly to make it. So anyway, I got rid of that nasty resonance that was annoying to me. It only came across maybe 1 out of 20 or 30 CDs I was listening to, but it's annoying nonetheless. And I think I've resolved it pretty well. I'm still under 30 components in the crossover.
Howard.
So Dave, tell us remind us again what the drivers are in these speakers you put together.
Okay. The woofer is a 10-inch C's. It's a P25 REX 10-inch. It's I believe, polypropylene cone. I got it several years ago because it had fairly high power capability, and it was over 90 dB efficient.
Okay.
However, it didn't measure to the manufacturer specs, so I didn't know what to do with it. So it sat on the shelf for about 12 or 15 years.
Wow.
The mid-range is another C's driver. It's a little 4-inch, the coated paper cone. It has a tacky coating to it. I believe it's a 10 FM. I think they used those in the Bang & Olufsen speakers from the 80s or 70s or something. These were salvaged out of that. I got them at a swap meet one time. the tweeter is an Audax 3/4 inch titanium dome, titanium, unobtainium. And those are they're all about 15, 20 years or more old.
So how does it play classical music?
What's that?
How does it play classical music then?
You can really pick out the detail on the different instruments. It's quite clear. The drawback with such a complicated crossover is it uses up a little bit of the power, and the overall efficiency is not quite as much. Part of the reason is I put in quite a bit of baffle step, a full 5 dB baffle step on the woofer.
Wow. Okay.
So because the resonance on the woofer and the Q on the woofer was pretty high in free air, so I used a damped vent, aperiodic vent, which made everything a little bit tighter, but I think I used up a little bit of the sensitivity in that process. But overall, it has a really nice, I think it has a pretty nice balance to it.
So you have this all mounted in a cabinet, right?
Well, let's see. Can you see back behind me there?
Oh, yeah.
Oh, right. Yeah.
So the crossover is sitting on top of the box right now.
Okay.
Oh, okay.
So it's open and available for me to tweak it, but I think I've got it where I want it now, so I'm probably not going to do much more to it.
Nice.
So
Very nice.
Now I've decided, since it does sound as good as it does, I'm going to go ahead with the cabinet, and I've got some nice plywood and some nice wood to make the new cabinets with.
Oh,
And I'll mount the crossovers inside when I'm done.
okay.
Oh, you can maybe see, can you see both of them? Is there enough light in there?
Yeah.
Room? So
Oh, I can see one of them.
I was playing around with, can you see both of them?
Yeah.
Yeah.
Okay. I was playing around with different ideas for grill covers. One would be covering the entire area, and the other one was just a minimal, just
Right.
covering the minimum amount. Yeah.
Yep.
So I'm not sure. I'll probably just use the full, cover the whole thing, and
Yeah, that looks nice.
yeah, it'll look a little bit more finished that way.
Yeah.
So
Cool.
anyway,
Yeah,
been
but
a COVID project.
Yeah.
Dave, that extra material is probably going to cost you 30 or 40 cents. Are you sure that you're ready for that?
Well, what I was trying to do was make the minimal amount of coverage so that it would expose more of the nice wood behind it. That was my thought.
Yeah, you probably waste that other material just cutting it out to size anyway.
Oh yeah.
Not like it comes out of the
Material and time. It took a lot of detail to cut that out.
All right.
But the plywood is actually very strong. It's really stiff, and it's not gonna, you can flex it pretty good and not worry about breaking it. So
I have a comment on the what Dave was just talking about in his little notch network. I was just thinking about that, and it occurs to me just to think about how these things work. But Dave was talking about implementing a parallel network. So the parallel resonant network will go to a higher impedance, okay, at the resonance frequency between the capacitor and the inductor. Okay, so he used what, a 20 microhenry inductor and a 14 or 15 microfarad capacitor, and that will end up resonating at a frequency around 8,500 hertz. The degree to which the impedance will rise will depend on how much resistance he shunts that with. Okay, because that will restrict it. In other words, if the inductor and the capacitor were perfect, in other words, they had no losses, the impedance at that frequency would go to infinity. Okay, so you have to limit that rise in impedance. In other words, the amount of energy you want to remove at that frequency by putting some kind of a shunt resistor there to stop the impedance rise. Now, I thought about, Dave said a choice between doing a series network and a parallel network, but think about a series network, okay? The series network, when it resonates, will go to 0 impedance at that frequency, okay? So you put a resistor in series with it to stop it from going down to 0, okay? But it's working, you think about it, the series network is working against the impedance that it sees in the circuit. And that may, if you've got a big capacitor, going back to your amplifier, it says the amplifier is now going to see this series load. So if you notched it down to a 1 ohm impedance, the amplifier will see 1 ohm at that frequency, stopped only by the series capacitor in there. So a parallel network, I think, is more benign in terms of its effect on the amplifier.
Right. Yes, I did actually see that in the simulations. I tried both. And I didn't mention it, but yes, I did add a resistor in my notch in both cases that I tested. I forget what the value is in there. It's around 15 or 20 ohms.
So it's always good when you've done a crossover, okay, to put in the simulated loads of loudspeakers with their series inductance, whatever, and then look at the input impedance of the whole network in your analysis, because you want something that the amplifier can drive easily. If you look at a lot of modern speakers now, which are tested, they're rated at 4 ohms, but you look at the impedance going down to 3 or 2.5 ohms. This is ridiculous. This is just bad design. If you're going to spec a speaker to be a 4 ohm load, it really shouldn't get below 4 ohms. Okay, so it's one of the interesting things about Dave's series networks, okay, is they often look very benign in terms of the amplifier load. They look very uniform across the entire frequency range, which is really probably one of the reasons why his series crossovers sound so much better, because the amplifiers have less trouble driving them than they would with a standard parallel crossover.
Yeah, on this particular one, being a 3-way, it's not as flat resistive looking as some of my 2-way speakers have done, crossovers. However, the overall impedance on this whole 3-way is between 5 and 8 or 10 ohms max, except at the resonant peak of the woofer, the vented woofer, it goes up to like 15 or 20 ohms. It's less than 20 everywhere, and it's fairly straight, fairly resistive load. And in fact, you were talking, Rene, about the series notch that you could put in, shunted across the driver, RLC in series. Yeah, it does go down. In fact, I did use an RLC series resistance in this whole network, and it was to get rid of the impedance peak from the woofer to mid-range. And it does. It had a peak about, it was almost 20 ohms, and it dropped that down and got that fairly flat. Yeah. And like you said, the notch, the series notch, has a very low impedance, and that's what what's the word I'm thinking of? Not the opposite of subdue, but
yeah, but I mean, of course, the amplifier will see that as a load. But like you said, if you're trying to tame a high impedance in the whole network, okay, using that series network, you can tailor it. The other thing, of course, is that it also compensates to some extent for some of the phase anomalies through the crossover. So you end up with smoother phase transitions, and the amplifier cares about both the resistance and the phase angle.
The lower resistance has a higher influence on the overall amplifier load. Yes.
Right.
And I did see that. That's one thing I really paid attention to on this design, was the acoustic phase. All these little things that you change in there can affect the acoustic phase, and I was trying to get the best balance of everything overall For the most part, it's down around, at most, it's 15 degrees off in acoustic phase, which is fairly good.
Wow.
So right at the crossover points, it's 0 to 1 degrees off, but over the crossover regions, it goes out as much as 10 or 15 degrees. So it's actually, it sounds pretty good, in my opinion, until I hear otherwise.
Dave, how are you knowing what the phase is?
With my simulation software, when I made the original measurements, it measures the phase, and load that into the simulation software. And as you start building the circuit, it keeps track of all that acoustic phase with the whole system. And you can just keep an eye on it while you're going.
Okay.
Yep.
Hey,
So it's
Dave?
all dependent on my measurements.
Dave?
Hello.
Yeah, how is that open baffle project coming?
You know, I've had,
Lost it.
it's open.
Open
I
project.
was wondering if I was looking for another set of crossovers.
Okay, rub it in.
Yeah, I'm kind of at a loss to proceed until I get the matching pair here. So
Yeah,
let me know. Keep me updated, please.
okay.
Maybe you could solve that with FedEx or something.
Hey, I've got a question for the people that are here. If this COVID thing gets over around New Year, or maybe, you know, a month or two, one way or the other, would we be having, I was going to say speaker contest, but I think we're back to the time for a DIY meet. Is there anybody up for that, or do you think that, well, I guess it depends on when everything calms down a little bit on the disease front, but.
Yeah, I don't know. I haven't heard anything that optimistic yet. So far, I've heard 9 months.
Yeah, yeah.
But yeah, I don't know. We got a few things yeah, between Dave, I've accumulated parts. I haven't built anything. Howard's built some stuff. Dave's built some stuff. Yeah.
My cabinet making has been on hold because we had gravel delivered last week, and so
Oh, nice.
gravel interrupted us there.
Yeah.
Did you get somebody to come spread that, or did you have to do it?
You know, the truck driver did an amazing job.
Oh, nice.
He knew just exactly when to start driving and at what speed, and the little pile at the end of his run was just exactly the amount you needed to rake it out. I mean, the guy was phenomenal.
Wow.
Yeah. So we got the driveway. The only problem where I had to do a lot of shoveling and raking was around the barn where he couldn't drive.
Right.
So.
There you go. Well, you shovel a little gravel every day. Makes Dave a strong boy. There you go.
Yeah. And dream about it.
If you have a big enough hammer, you can make your own gravel.
Yeah. Yeah.
A real DIY project.
Nice.
Well, I could say a few details about what's going on with my open baffle.
Go for it.
Okay. So on one of our meetings, I think it might have been the last one and the one before that, a lot of time has gone past, but I showed a big box that was a mass-loaded transmission line, which is essentially a vented box that uses standing waves with a 10-inch driver in it. And I really liked the sound, and maybe it wasn't, you know, perfectly distortion-free or whatever, but I liked it. But it was too big, and I opened up that box and filled it with chunks of wood, about a third of its volume, and it still did about the same thing. I mean, I didn't measure it, and so I don't, you know, it's probably taking a few more watts to, or a little more power to make the same level of sound at 30 hertz or whatever, but it's working. So my goal was to come up with something that would sit behind my narrow open baffle and not be visually obtrusive. And I've drawn something out full scale, which seems to do that nicely now. So it's a happy thing. And the driver is another vintage driver. The main drivers in this thing are an 8-inch JBL, probably from the early 60s, and a Bozak 12-inch from anywhere right in that range, 1960 or so. And this is a JBL. It's a little later approach, a little heavier cone, but it's from probably around 1970 or so. It could have been from anywhere in there. I haven't checked the serial numbers. One of the ones with the white stuff sprayed on the cone. So, and it's an Alnico. So there's the main drivers in there are all Alnico now. So I'm being happy about that. And another thing that I did was I had been trying to avoid a little bit of metallic sound in that JBL driver because it has an aluminum extended range cone on it. And I wasn't that happy with the transition that was making to this 4.5-inch Fostex. And so I decided, well, let me see what happens if I just run the JBL up higher, don't try and roll it off so much, and just accept its sound. It's because this is what I'm building the whole thing around is this sound of this vintage driver. It has a particular sound, not particularly audiophile the way things go these days, but it's a particular sound, and I wanted it, and so I'm liking that. I just raised the crossover point by 1,000 hertz or so. So I'm liking that. And then the other thing was I made the that 8-inch into pretty much just a true mid-range. Didn't try and run it down. I think it's probably crossing over somewhere around, I don't know, just a wild guess, around 500 hertz or something to the 12-inch Bozak. And I'm liking that better. And for my home use, wouldn't work for speaker contests, but for my home use, I'm going to tri-amp this, I think. And what I'm finding really handy, especially with the open baffle, you have this huge baffle step because of all the losses with not having a box. And so I'm finding it really handy just to be able to use a separate amplifier for the lower frequency speaker, which ends up being less efficient in this case. I mean, you could have a less efficient mid-range, you could, but this one's not. And I can just crank up the volume on that low frequency speaker, and if I get the crossover point in the right place, there's no attenuating anything to make a baffle step. You just raise the amount of watts that the larger speaker is getting. And there's only passive crossovers. It's not going through a DSP or anything. And then also I have a plan to be able to use variable L pads and so forth to be able to run it off of one amplifier if I want to. But mostly it's set up to use a little SET to power the higher end part, which is quite sensitive. And then some solid state amps on the lower part. So but with open baffle, it's just, if you can use maybe 2 amplifiers, one for the big speaker on the bottom and then another one for the one on the top, you can just adjust the levels if you use like integrated amps or some kind of volume control. And you can totally balance out the low frequency output with the higher. You don't have to have this big rising response. And you do it around whatever the baffle step is, which is going to be different shape of a roll off and whatever than if you have a closed box with a baffle step, but still it's there. So all that has been happy little tweaks. And I think where I may get a little more sophisticated is in whatever I use for the subwoofers crossover, because right now I've just got a plate amp and it has a built-in 18 dB roll-off and sounds okay, but I'm just not sure it's integrating frequency rise that perfectly with the open baffle. There's a subwoofers in a box. That's the mass loaded transmission line, or in LTL. So that's the news on that front.
Oh, cool. Wow.
Yeah.
What was I going to do? Oh, I was going to ask Rene if we talked briefly about tubes last time we were on the phone. Have you identified some tubes you're willing to part with for money?
I have a whole bunch of them. I'll count them and see how many there are. I'm sure. Yeah. If you're really serious about doing that 6DJ8, a parallel 6DJ8 amp. Yeah, I have a lot of them. So.
Oh, fantastic.
Some people like it a lot. In fact, Michael Jukers has been playing with a Theta digital early tube preamp, and it's full of 6DJ8s, and he thinks it's the most wonderful sound, even compared to his thing that he's been doing, which would be a 6C30 Russian tube. So,
oh yeah. Wow.
Anyway, so 6DJ8s are nice tubes. I mean, Conrad Johnson liked them too. I use a lot of them. So it's a good.
Right.
Anyway, got a bunch of them, so I can certainly get them over to you if you're serious. And of course, you'll need a schematic.
Yeah, yeah.
And maybe some pictures as to what the hell I tried to. That brings up another thing too that I wanted to mention is a couple of weeks back, Dave Rosegard sent out an email to some of the club members about this guy on DIY Audio had a bunch of Ionetics single-ended output transformers for sale. And he still has a couple of both level 1 and level 2 transformers, which Bud designed for 2A3s, but I went and looked at the specs, and they would also work for 300B. So if anybody's interested, there's still a bunch of them on. I think the level 1, he only wants $240 for a pair, which is really a good deal. He wants a lot more for the level 2. The level 2, I think, lits wire, secondaries and stuff, better insulated, more interleaves and so on.
Wow.
The other thing I noticed this morning looking through the website of some of the suppliers is that Angel Instruments sells a pair of 300B or 2A3, whatever, monoblock chassis, aluminum, and they come with all of the parts. It's a pair, all the parts with end caps, okay, for $149, which is like for two monoblock chassis. So if somebody wanted to build a 2A3 or a 300B single-ended amplifier, those are two good deals. You know, so for like 240 plus 150, whatever. So you're talking about $400. You've got some of the basic stuff. You'll need a power transformer. You'll need a couple of power transformers and all the other parts. But hard to beat the prices. So anyway, I can attest to, and several others can attest to Bud's transformers. They really are amazing. Even the level 1s are quite good.
Wow.
So if anybody needs a flea power amplifier, you know, 8 or 9 watts from a 300B and what, 2.5 watts from a 2A3.
Yeah, both
cool.
my single-ended amp and my headphone amp use output transformers made by Bud, and I'm happy with them, I'll have to say.
Yep.
I have a question about tubes in general. Rene, hopefully you can answer. I'm sure you can. I'm just trying to understand. I've thought about making a phono preamp, and I can't quite find in my research a straight answer on how much gain you need on a phono preamp. I know there's a difference between moving magnet and moving coil. And I get answers anywhere from 50 times gain up to 600 times gain, and I'm not sure what's what. Can you shed some light on that?
That's about right.
Okay.
Maybe we could take it a little further. Maybe it's
Okay.
50 times up to maybe 1,500 or 2,000 times. There are moving coil cartridges with such low output that you need a huge amount of gain, like 70 or 80 dB, which is pretty absurd. I think Gary Coe has one of those. I think it puts out microvolts at 5 centimeters per second.
Okay.
But the such challenge is trying to build anything that would amplify that correctly. I wouldn't go that way. The first thing is to figure out what cartridge you're going to be using, what phono cartridge you're going to be using. And there are, there's a number of candidates in the $200 to $500 range that apparently are extremely good. And maybe some of the people who listen who have an investment in vinyl could probably point to some winners. So anyway, I know Robert plays a lot of vinyl, or used to. Renan plays vinyl. So something to first decide what cartridge you want to use. If it's a moving coil, then you want to design rough gain for a moving coil. And if it's a moving magnet, then you don't want to have too much gain because you can risk overloading the phono preamp. The other thing you have to remember is if you also have a preamplifier in your chain, okay, and an amplifier with high sensitivity, you may be able to make up a lot of gain from the preamplifier, but you don't need as much in the phono section. So it is actually, overall kind of a matching problem. So I think start with the two ends. Look at your loudspeakers and your pickup, and then work backwards and then figure out how much you need in that phono stage. It's probably best to design the phono stage, phono preamplifier for the correct gain from the beginning, rather than trying to make one that has, selectable gain. That always adds problems in the design. So, do you have a cartridge at this time?
Well, I got that old turntable that I think Barron was giving away at the club here last year.
All right.
I don't have it in front of me because I gave it to the grandson, and I was thinking about making something for that. And I'm pretty sure it's a moving magnet cartridge, but I don't know what the part number is or anything and the specs on it. But I can go look at that sometime and figure that out.
Send me an email.
I saw one place, there was a reference on one of the forums to vinylengine.com. They have a database that you can type in the cartridge number and it'll give you specs information on it.
Right.
So I'll see if I can do that research and get in touch with you.
Yeah, right. Okay. So this wants to be a tube design.
Yeah.
Okay.
So I was thinking, so another question is, say I see a lot of these phono preamps have two tube stages, and they've got one that say they want they might use a 12AX7 and then something else in the follow-up stage, and they might have, so the gain on the amplification factor on a 12AX7 is about 100, and then the next one might give it like 10 or 20. But depending on the circuit, what the circuit does, they might have a total gain. How does that do? Do they multiply the gain of the first stage times the gain of the second stage to get the total? Or do you add them, or are they added in decibels and then figure out the gain?
They're additive, except you have to remember that you have to deal with a low frequency equalization. So when you look at a phono preamp gain, they specify it at 1 kilohertz in the middle of the thing. I don't know if you ever looked at the RAA playback curve, but it has almost a 20 dB boost at low frequencies and a 12 to 15 dB cut at the high frequencies. So you've got this huge range of gain. specified at 1 kilohertz, that's what you're looking at, because the cartridge's output is specified at 1 kilohertz.
1 kilohertz, okay.
But you're going to need excess gain, whether you do a passive equalization, okay, where you just throw away 20 dB in order to get
Right.
the gain, or whether you do a feedback, you still need to get that extra gain. So in other words, if you needed 40 dB gain at 1 kilohertz, you need 60 dB gain overall in order to get your, to properly equalize at low frequency. So 50, you know, a typical 12A7 in a real circuit, you'll only get a gain of about 50 from it because of the loading. And so if you have additional stage, which has a gain of 20, okay, well, that gives you 1,000, there's your 60 dB. So you have a 12AX and a 12AU will just barely do it. If it's a feedback design, you want a little extra because at the lowest frequencies, you still need a little bit of gain in order to meet the curve properly. But anyway, there's a number of good designs.
Yeah.
The one that I built last was the based on the EAR 834 phono amp, which Renan is familiar with. It's a well-known design, and it sounds really good.
It's very good. Great.
It is, yeah. Uses 3 tubes. And on eBay, you can find a number of Chinese suppliers who will sell you a board for this tube circuit. And that's what I bought the board, I think, for 20 bucks or something, just out of curiosity, because I was really, when I saw the schematic for the preamp, I was intrigued because it's an unusual way to do the feedback design. So I said, gee, I wonder how that works. So I bought the board and populated it, and it's a wonderful sounding preamp. I mean, it's as good as the tubes you can find to plug into it. So I put in a really, nice old telefunction 12AX input, and then I used 12AT7 for the remaining, which is a very good sounding tube, not significantly appreciated, and it meets the RA curve within a quarter of a dB, from 30 hertz all the way up to 20 kilohertz, and sounds terrific. And not only that, it's quiet enough that I can use it with, even though it's designed for moving magnet, I used it with my moving coil cartridge, which is a medium output cartridge, and it's still dead quiet. So it's a good design. And as I said, you can get a board, you can find a board on eBay for it. So.
Which, you said it used 3 tubes or 3 stages of tubes. What tubes did it use?
The output tube, it has an output tube, which is a cathode follower. So you get a low impedance output. And it's also the cathode follower then can drive the feedback network properly. So it's 3 dual triodes. So, and they're used split left and right. I mean, a lot of people say, oh, you can't do that. You have separate tubes for left and right. It has, I wouldn't worry about it in phono preamps. My thing about phono cartridges, if you find a phono cartridge that has better than 26 dB of separation between the 2 channels at high frequencies, tell me where it is, because it doesn't happen. Phono cartridges already have board separation. In fact, there's a legendary cartridge, the old Deca moving coil cartridge, which relied on the fact that there were certain kinds of crosstalk between the left and right channel. And the crosstalk occurred because the Deca cartridge was designed, it had coils that were at right angles to each other, so that there was a vertical coil and a horizontal coil. And in order to get the 45-degree 45 output, they matrixed the 2 coils together. They subtracted the horizontal one from the vertical for one side, and they added it to the other side, and so you get a left and right signal, okay, by matrixing. The Deca cartridge had an actual screwdriver adjustment on the vertical coil. It would adjust to get the best separation, right? The best sounding cartridges that people found, it turned out the coil had been over adjusted so that there was a negative separation, so you had minus left and minus right in the opposite channel. And this causes the image to spread way out. And that became the, so that was the secret. So actually, I often thought, I said, why don't we just design a phono preamp that allows you to tune it? You know, and anyway, I've never seen anybody do it, but maybe that's the secret of some phono preamps, is that they actually have some of this sort of inverse crosstalk, and so they sound really wide and open spaces.
That'd make a good DIY project.
We could do that, yeah, sure.
If you got 20 years.
Well, Dave wants to build one, so you know. But anyway, but you could do this cross cancellation thing, you know, with any kind of a circuit. I always wanted to put it into the preamp, into the line level stage, where you could have the ability to adjust it. In fact, somebody did that, and I'm trying to remember who it was, but I had seen designs where in the preamp, in the main level preamp, you could actually take and you could combine the low frequency energy and make for instance frequencies below 50 hertz be mono, so those speakers, you know, take it, and then the upper frequencies you have separation, and you could add a little bit of minus, you know, less than minus while you know, channels and get some of it. But anyway, that would be an interesting preamp anyway. I have several designs on paper over the years, but I've never built one. So.
Hey, can I ask a question?
No, go ahead.
Go ahead.
Oh. No, can you hear me?
Yeah.
Yes.
Oh yeah, go ahead. You can ask another question too.
Yeah, okay, thanks. Yeah, I saw that John Curl is selling his amplifier. What does he call it?
Oh, the blowtorch?
Blowtorch.
Oh.
He builds them himself and he sells them, and he's asking $2,000 brand new. Is that a pretty good deal? I've never heard one. Has anybody ever heard one of those? No?
No.
No.
He's got a good reputation. I don't know how good his stuff is. Maybe Rene knows. I don't know.
Sounds like something that would run fairly hot, don't you think?
It's called the blowtorch.
Yeah.
It was over-designed Class A. In other words, lots of current capability in all the stages, whether you needed them or not. It ran very hot, but it sounded, it's legendary, as we say. The sound is legendary, whatever that means.
Means you'll never forget it because your ears hurt so much, or what?
Well, it seems like we need Terry to go ahead and buy it and listen to it and tell us about it.
Yeah. Never stop remembering how much money you spent for this thing.
Yeah. But I thought that $2,000, if it's got a lot of stuff, it might be a pretty good deal for somebody that's looking for one.
Well, the trick is, if you buy it, make sure that John Curl signs it. He puts his name right on the top. Then it will have real value.
Yeah.
Because he is legendary. I mean, you know, he's done a lot of great designs in his time.
Yeah, well, that's true.
I had some single malt with them back in the day.
I've got a question that might be best for Rene, but anyone can chime in. Dana, you might know. I was looking at, I have an old AV receiver from, I think it's from the late 80s. It's a Yamaha, and it works except for the display doesn't go. And I was thinking it was the display was shot or something that drives it, but it turns out that online there's a forum and the guys say, oh yeah, that whole line of receivers has a single bulb, and it's a filament bulb, and it's like 14.4 volts or so, and it's 6 millimeter little bulb with a couple of leads on it, and you just splice in the leads and pop the bulb in, and I don't know, maybe you have to glue it in or something, who knows. But the one I found on Amazon that would go for it says it's only good for 1,000 hours, and I'm thinking about a solid state amp. If I was thinking about using this, it's just using the amp section in it. It's 80 watts a channel. It's supposed to be real nice sounding. I never really had it hooked up to big speakers or anything. And I thought 1,000 hours, you could get there pretty quickly if you left your amplifier on all the time. So is there an alternative for that? An LED or a some
white
other?
LED. A white LED with a
Oh
resistor.
yeah. An LED and a 1,000 ohm resistor, and you're in business.
Right.
Okay.
Lasts
Right.
forever.
So you just 1,000 ohm resistor just goes on one side or the other of the leads, and
It's a little bit more complicated than that because it's being fed with AC, right?
well, it's 14 volts. Isn't it all rectified or no?
If it is rectified, then you just have to be careful of the polarity when you hook up the LED. Because remember, an LED is a diode.
Okay.
So it has to be in the forward conducting mode.
And will it just not work if it's not, the polarity isn't right, or will something happen to it?
15.4 volts, it'll probably zap the diode because the reverse voltage on LEDs is not very high. It's typically 5 or 6 volts. So you'll be overvolting it and you might break it down.
Okay.
Yeah, so you have to be. Now, the other thing to do, of course, is you could put another diode in parallel with it, you know, in the opposite direction, and then put the resistor in series with those. And it doesn't matter which way you hook it up. If it's AC, it'll light. Now, of course, if it's DC, it won't only light if you hook it up the right way. But
so I would just look for a an LED that was just right physical dimensions, and then just go from there, glue it into place or whatever, huh? Yeah.
Right. Yeah. Tell me the dimensions of the bulb. I have a ton of white LEDs and other colors, whatever color you like.
Okay. Well, I mean, the bulb itself is I think it's supposed to be 6 millimeter around, and then the length of it is about, I'd say, 4 times that, something like that.
Long and skinny, but the leads are at one end, right?
Yeah.
Okay. Yeah. Okay, now wait a minute. Now how is it used? Is it pointed using it head on?
You know, I have to open it back up again to see, because yeah, I'll have to see. I think it pokes into a hole, and it backlights the display.
Right.
And all the references all the references I saw online said that yeah, that's probably what's wrong with it. And
right.
And you know, one guy on a YouTube said, yeah, well, the way you can tell for sure if it just needs a backlight is that you can take a flashlight and shine it in at an angle and see if you can see you know, the readout for the FM station or whatever's up there.
Yeah. The thing to remember, of course, is that the incandescent light is pretty much an omni-radiator from the filament, whereas an LED has a fairly narrow angle of illumination. So it may be too narrow, and you may find out you need the wider spread, you know.
Yeah. Is that, I mean, 1,000 hours, that seems like an awfully low number of hours for a little bulb that's part of a piece of equipment.
Well, if it's 14.4 volts, I'm not sure why it's 14.4 volts, and they're using the 12 volt incandescent light, it isn't going to last very long.
Yeah.
Right.
You gotta know that incandescence, right? The lifetime goes at the 9th power of applied voltage.
Yeah, it's
really important.
I think the bulb that's on the bulb on Amazon is 14 volts.
Yeah, but still, 13 and 14.4 is still too much. That's why you have to be careful about like tube filaments. You don't want to run them at 0.6 of a volt over. You want to run them at 0.6 of a volt under 6.3 volts. Unless it's a power tube.
Right. So I mean, if I did find a bulb that was 18 volts or something like that, if there was such a thing, then it would be a little dim maybe, but it would be.
It'd be a little dim, but it would last a long time.
Right. Okay.
Yeah, there's a lot of dim bulbs in the world, no doubt about it.
I have some called incandescents. Maybe those typically you could use them anyway. Yeah, first get your bulb out and let me see what it looks like. Take a
Okay,
picture of it.
yeah, I'll do that.
Picture of it to me, and then I can see what I have something. Okay.
Okay, cool.
Yeah.
Yeah, Howard.
Yeah.
So these are surface mount LEDs.
Yeah.
And so these little guys are 4 millimeters wide and probably 6 millimeters long. What is it?
Mhm.
And these ones are particularly nice because they have they're white. They're kind of they're 6 millimeters long and 4 millimeters wide each one. And so yeah, probably I could hook one of those up with a 1,000 ohm resistor and some wires and stick it in a little plastic tube maybe, or who knows, and make it look like a light bulb.
Yeah, that's what I was trying to think. Is if you use one of those surface mount types, the radiation angle is much wider than typically when
because
it's plastic. Yeah,
because there's no lens. It's just a surface that illuminates. So it's
right.
the full 180-degree illumination. Right. So they're really nice.
Yeah.
But,
yeah, if you could use that would be the way to get the.
Yeah, they're just a bitch to solder wires to.
Right.
So I could try that, see if I can do something for you. And you could, if Renee's got something, you might try that. Depending on the radiation pattern, like he says, one may work better than the other will. Yeah, you find out. Or the color. I don't know what color it particularly is looking for. These are going to be pretty much the same color as an incandescent bulb. So.
Okay, right. Yeah, that's probably what you want. Probably just something with a little bit of. I mean, white would probably work fine, but a little bit of yellow would probably be fine too. Yeah.
Red adds a certain amount of danger.
Nice.
I think the letters are red, Terry. So I want some contrast.
Oh, okay.
So I got a thing that I think you guys should see here. If the screen share still works, I'll put it up.
Yeah.
Oh boy. Don't show that around.
Busted, huh?
That should be banned.
How do you get that thing to ever turn off to test it,
You know that thing they implanted in your brain last year?
Oh my gosh.
Oh boy, yeah.
Well, I saw that on a guitar amp site, and so I snagged it because I thought of you guys.
Nice.
And me.
Hey, Gary?
Yeah.
What's that behind you? Are you on your space station?
This is the International Space Station, yes.
Yeah. How did you do that?
Well, I have a green screen that I got because I do all kinds of video production things for my online instruction stuff. And so Zoom is designed to work with either a green screen or you can, depending on your computer, you can possibly use a virtual background without having a green screen, but it's kind of kludgier and it doesn't work with every device. But then you choose a photo. You can browse the internet, just look for Zoom backgrounds, and there are all kinds of pictures that people have gathered up that let you download. And so for a while, I was doing a different background for each. Every time I come back to the same meeting, I try to be someplace else. And anyway, this is the International Space Station.
Yeah. Do you propose to your wife that you take a trip on the TV screen?
Haven't tried that, but I had some fun though, because we were doing a virtual video for Bremerton Symphony, and so I filmed her playing a violin part, and then since it was in front of a green screen, I played a little trick on her, and I showed her, playing violin over a bed of hot lava and all these different things, and it was a little bit fun.
Yeah,
I'm having the same fun too. I've got the.
So you have a physical green screen behind you, and then the image.
I do. I can have whatever I want behind me. I like this one back here.
Oh, okay.
That's just my driveway. the house. You know, I mean, there's all kinds of weird things you can show.
Oh, for crying out loud.
You seen this thing? This is amazing. This is in, they built this in New York City recently. It's incredible. I used to know
So
it.
Gary, I have a question for you,
Wow.
Yeah.
Gary.
Yeah.
So when you do your recordings for this for your symphony with your sound devices, what kind of microphones do you use, and where do you place them, and so on, when you're recording the orchestra? Or I mean, what have you been using the sound devices for?
Oh, yeah, that's more the question, because I have been using the sound devices stuff for recording myself as an individual, or my wife, or individual singers, or the keyboard at the church.
I see.
And so I have I usually use either one of my AKG condensers, perception series condensers, or I have there's another condenser, and I can't remember the name of it right now. But it was a bunch of experimenting at first, because boy, a placement of microphones really
Right.
it's pretty critical.
Yeah. But then once you've recorded it, you use it then for a live stream or something? I mean, not a live stream, but some sort of streaming facility or capability?
What we were doing all summer was that we were pre-recording all of our for church, and that's what I did most of the recording for.
Oh, okay.
If I was doing recordings of myself for a Bremerton Symphony thing, I would just send the recording, and then they had other people who would do the audio editing and video editing. But
Okay.
for the church, I was doing all kinds of things that I was recording people individually and synchronizing them, but I wasn't doing video with that. I was just synchronizing separate performances of vocalists and instrumentalists. And then we would put it on it would all get put together into one MP4 and then uploaded to YouTube.
I see. Okay.
Now we
Got
are
it.
doing streaming, and so we're doing things live, and we spent nearly $10,000 on video switching and robotic cameras and all that stuff. And so
Wow.
I had quite a learning curve with that. I'm only a few weeks into doing that from in the sanctuary, but
Nice. Great. Good. Thanks.
Wow. Yeah. Cool.
so now yesterday I was given an assignment to record something and video something with my timpani. And so far, all my recordings for orchestra have been small things that my timpani are in the garage. That's not really a very photogenic place. And I can't get them through a door into my house because they're bigger than the doors. So what I'll probably have to do is do the audio recording in the garage, and then take them outdoors, and then do filming synced to that. And we do that a lot because you can get better lighting outside more easily.
Great.
But it's a big mess.
Yeah.
It looks like Renee's in space right now.
Zero gravity.
We have so much fun with
Pull back on the stick.
Oh my gosh.
Okay.
Excellent.
Oh, boy.
Right.
Oh my goodness. Well, I guess we've gone 2 hours. Anybody have any other audio goodies, or you want, or we can take
Hey,
what everybody.
that's the RV.
That is the RV. So there's, you can see my new speakers I bought. There's one and there's one.
Oh, wow.